Okay, so let's start with another exercise, correlation, that is correlation matrix. So let's first clear all these outputs which are there by clicking on this, and we'll clear all these outputs which are already there. Then we'll start our exercise, right? So everything has been cleared that we can check, and now we are going to start from the beginning, right? So in this we'll be constructing a correlation matrix. Each row and column represents a correlation matrix, and there is a variable, and each value of this matrix is the correlation coefficient between the variables represented by the corresponding row and column. The correlation matrix is an important data analysis metric that is computed to summarize and to understand the relationship between various variables and their decisions. It is also an important pre-processing step in machine learning pipelines to compute and analyze the correlation matrix. We mentioned how each cell in the correlation matrix is a correlation coefficient between two variables corresponding to the row and column of the cell. Let's now understand what is correlation coefficient in this exercise that we are going to work on. So what is correlation coefficient? So we can run this, nothing will happen, of course, right? This being all remark. Then what is correlation coefficient? Correlation coefficient is a number and denotes the strength of relationship between two variables. There are several types of correlation coefficient, but the most common of them all is the Pearson's coefficient, right? Denoted by letter rho or small p. It is defined as the covariance between two variables divided by the product of the standard deviation, where the covariance between x and y, that is COV x and y, is further defined as the expected value of the product of deviations of x and y from their respective means. Plotting the corresponding the correlation matrix. For the explanation, we will use data set that has more than just two features. We will use the breast cancer data, a popular binary classification data. We'll load this data from our scikit-learn library, that is sklearn dataset module. It is returned in the form of a NumPy array, but we will convert them into the pandas data frame. So for that we are going to write this code, that is from sklearn dataset import load breast cancer, import pandas spt, breast cancer is equal to load breast cancer, data is equal to breast cancer dot data, features is breast cancer dot feature name. Then all the features will be available in the features now. Data frame df is equal to pd data frame, data column is equal to features, then print df shape, and then print features. So when we do this, we will see all that what is going to happen. So after completing this, let us run the other part also, which we have not done. So let us run this. Let us run this also. These are all remarks, so nothing will happen. Then we are going to run this also, right? Now we are going to run this one which we just mentioned. So when we run this, you are going to get the shape of the data set and so right now it is in process. So once it completes, we get the shape of this data set, that is 569 rows and 30 columns, and the features are mentioned here, like mean radius, mean texture, mean perimeter, etc., etc. So all the features which are in 30 in number are all available here. Then we are importing the seaborn as SNS, import matplotlib also .pyplot as plt. Then we are also taking the all rows but only 6 columns. All rows are taken but columns only 6 have taken, not the 30 columns, right? So for that we have to write this code, that is df small df.ilocal. So because here we are taking all the rows, so nothing has been mentioned here, and here we have mentioned 6 because 6 columns are being taken. So all these codes are very important, one must learn it. Correlation matrix is equal to df small correlation, that is because it is here, so we are using this for the correlation matrix. And SNS heat map correlation matrix that we want to generate with annotation as true, and then we are going to plot. So once we give this command for plotting, you will see a heat map will get generated. That is how you will get a heat map, right? So this is the heat map, and you can see, since we have mentioned about 6 features, so only 6 features are available, both on the y-axis and the x-axis here also. And these are the annotation, that is the values which are available in each cell, that is also mentioned. And this is the vertical bar that gives the strength of the correlation between the two variables, right? So that's how you can draw a heat map. A very good, nice looking chart. So the plot shows a 6 by 6 matrix, and color fills each cell based on the correlation coefficient of the pair representing it. Panda's data frame correlation method is used to compute the matrix. By default, it computes the Pearson's correlation. And we would also use other methods such as Spearman's coefficient or Kendall's, whatever you want to know, you want to run for, we can get that. Then coefficient by passing an appropriate value of the perimeter. When we use Seaborn's heat map method to plot the matrix, the parameter annotation is true, and that is how you get the values inside this cell. Let's now understand how to interpret the plotted correlation. So for that, we can run this also. Then one must keep the following points in mind in regard to the correlation matrices, that is, each cell in the grid represents the value of the correlation coefficient between two variables. Then the value of position A and B represent the correlation coefficient between feature at row A and column B. This will equal to the value of the position BA. It is a square matrix. Each row represents a variable and all the columns represent the same value. Then next is, it is a symmetric matrix, and this makes sense because the correlation between AB will be the same as that of the B and A. All the diagonal elements are going to be 1, which you can see here on this 1 1 1 1 1, and this you can see that since diagonal elements represent the correlation and each variable with itself, it will always be equal to 1. The axis ticks, they denote the features each of these represents. A large positive value near 1 indicates a strong positive relation. If the value of one of the variables increases, the value of the other variable also increases, right? Value of one variable if you see, decreases with the others increasing, and vice versa. A value here near to 0, both positive or negative, indicate the absence of any relationship between the two variables. That means there is no relation if it is 0. Each cell in the above matrix is also represented by shades in the color. The color indicates smaller values, while brighter shades correspond to the larger values, as I mentioned. This scale is given with the help of the color bar that is already there, as we have seen it here. Yeah, this one, right? So we can run this also. Of course, nothing will happen again. Then this is just for understanding. That is why so much of explanation has been provided. We can tweak the generated correlation matrix just like any of the matplotlib. Let's see how we can add a title to this, because title is always very useful. So we must include a title in the graph, any graph that you have. So correlation matrix, DF small correlation, SNS heat map correlation. Then title is correlation matrix of breast cancer data. X label, plot X label, cell nucleus features. Similarly on Y label also cell nucleus feature, and then plot show. So once we plot this kind of a graph, you can see now the graph will be much better looking, giving the title and labels, etc. Data is same, everything otherwise is same. Then sorting the correlation matrix. If the given data has a large number of features, the correlation matrix can become very big and hence difficult to interpret. Sometimes we might want to sort the values of the matrix and see the strength and correlation between the various features, pairs in the increasing or decreasing order. Let's see how we can achieve this. So first we will convert the given matrix into one-dimensional series. How to do that? You can see that correlation mat is equal to d of small correlation, then correlation pairs, that is correlation matrix unstack. So we are going to unstack that, and then we are going to print that. So for that, this code is mentioned for unstacking and printing the correlation pairs. So when we run this, you can see that it has unstacked also, and then in one line itself you are getting all the pairs, right? Radius, texture, perimeter, area, etc., etc. So all of them are available to you. You can go through just by moving up and down, and you can see, check it for yourself. Then the unstack method on the pandas data frame returns a series with multi-index. This is each value in the series is represented by more than one indices, which in this case are the row and column in the indices that happen to be the feature name. Let's now sort these values using the sort values method. So sorting method is, for that we need to write this code, that is sorted pairs is equal to correlation pairs dot sort values, and kind is, the method is quick sort, and we want to print this also, print sorted pairs. So when we first, let us run this one. So when after running this, we can run this also, so that you can get that. So once you get it, you can see that all this is all sorted on ascending order, that you are getting, right? Then we can see each value is repeated twice in the sorted output. This is because our correlation matrix was symmetric matrix, and each pair of the feature occurred twice in it. Now we have the sorted correlation matrix, correlation coefficient values of all pairs of features, and can make their decisions accordingly. So we can run this also. Then selecting negative correlation pairs. So we may like to select features pairs having a particular range of values of the correlation coefficient. Let's see how we can do that with a negative correlation from the sorted pairs as generated in the previous section that we have seen. So we can run this also. Nothing will happen, but now we are going to check for the negative pairs. So for that we write this code, negative pairs is equal to sorted pairs, sort pairs is less than 0, because we want to find out the negative pairs. So, and then print that, print negative pairs. So we can run this code, and now you are getting the mean texture, mean smoothness, mean smoothness, mean texture. So this is how you get this value, right? Now selecting a strong correlation magnitude that is greater than 0.5, right? So to get that, let's use the same approach to choose a strongly related features. That is, we will try to filter out these features pairs whose correlation coefficient values are greater than 0.5 or less than 0.5, as we have seen, right? So for that we write this code, strong pairs is sorted pairs, absolute sorted pairs, and that is greater than 0.5, and then print the strong pairs. So once we do that, you can get the again all the values more than 0.5, right? Now converting a covariance matrix into correlation matrix. So for that we have seen the relationship between the covariance and correlation between pairs of variables x and y, and covariance also x and y. Then the equation of relation between correlation and covariance. So let's understand how we can compute the covariance matrix of a given data in Python, and then convert it into correlation matrix. We'll compare it with the correlation matrix we had generated using a direct method call, right? So we have seen all that. Now we are going to run this particular cell. So we can run this. Nothing will happen, of course. First of all, pandas doesn't provide method to compute covariance, right? So between all pairs of variables, we'll use the numpys. That is why we need the numpys transformation. So we do this with the help of this import numpy. We have to do as np covariance is equal to np covariance df small dot t. That is what we have done earlier, right? And then print covariance. So when we print the covariance, you can get this kind of a output, right? Next is that we are passing the transpose of the matrix, because the method expects a matrix in which each of these features is represented by a row rather than a column. So we have gotten our numerator right. Now we need to compute a 6 by 6 matrix in which the value of I and j is the product of standard deviations and features of positions I and j. We will then divide the covariance matrix by this standard deviation matrix to compute the correlation matrix. Let us first construct the standard deviation matrix. So we can run this. This is of course remark, nothing will happen. So compute standard deviation of each of these 6 features. So for that we write this code, stds np std df is small axis shape 6 standard matrix, and then np array stds I stds for j in range 6, for I in 1 range 6. So you can, because we have taken 6 as the range, the maximum number, that is why we have taken the range as 6. I is the starting point, right? And print standard deviation matrix of shape stds matrix and shape. So we can run this and we get this output, right? That is the standard deviation matrix of shape 6 by 6, correct? Now that we have the covariance matrix of shape 6 by 6 of the 6 features and the pairwise product of features matrix of shape 6 by 6, we can divide the two and see if we get the desired result and correlation matrix. So we can run this, and now new correlation matrix that we are going to get with the help of this code, that is new underscore Corr CORR is equal to covariance standards matrix. So once we run this, you can see that of course nothing you are getting as output, but that definitely it has done its own work. We have stored the new correlation matrix derived from the covariance. So that is this data we have stored in this new covariance in the variable new Corr, right? And let us check if we got it right by plotting a corresponding correlation matrix and juxtaposing it with the earlier one generated directly from the pandas. So then we can compare the two, so that we can see that whether they are same or not, or what is the difference like, and things like that. So we can run this. So we can see that of course nothing has happened here because it is remark, but now with this code you will see the difference. PLT figure fixed size 18 by 18,4, then plot subplot 1 to 1. SNS is the heat map that we are going to get with annotation. Plot is title is earlier for the earlier one that we got, correlation matrix. Cell nucleus feature, Y label is again the same self nucleus feature, and then plot subplot 1 to 2, another plot that we are getting, another heat map. Correlation mat annotation is again true. Title is newer correlation, the next one that we are going to get from covariance. And labels are of course same. X label is nucleus feature, and then Y axis also we are getting the cell nucleus feature. And then when we are going to run this plotting it, you can see that the two heat maps side by side are going to be made available with the help of this. So you can see that earlier correlation matrix that we have got, which is as per the this is the code that we have written, and on left this Y axis we got this same content, that is nucleus features, and here also on the bottom also we have got the cell nucleus feature. Here you see the difference in the title, newer correlation matrix from covariance. Now earlier correlation and newer. So this is how, and the heat map, if you see, this is almost the same. There is no difference. Annotation and figures in that, everything is going to be same, only thing. So we can say that both are same. So we can compare the two matrices and notice that they are identical, right? So we can run that, and exporting the correlation matrix to an image, that also is possible. We can export it, and maybe this will be stored in our working directory. So let us see how that is done. So plotting the correlation matrix in a Python script is not enough. We might want to save it. So for saving purposes, we can export it to our working directory, and this can be used anytime later. We can save the generated plot as an image file as disk using the plt.save. So we can again run this. Now with this code, it is going to do all that we wanted. So correlation matrix is df small correlation, SNS heat map correlation matrix, annotation is true, plt title correlation matrix of breast cancer data, x label cell nucleus features, y label cell nucleus feature, and plot save figure breast cancer correlation.png. So it will be a png file that will get created, and it will get stored in your working directory with this code, right? So once we run this, you will see that it will do all that we wanted. So it has completed, and this image has been created with the help of this code, and a copy of this has been stored in your working directory, right? So you can see that after you run this code, you can see an image file with the name of breast cancer correlation.png. Whatever name we have given, with the same name, it gets created there in the same working directory. And conclusion is, so we learned what a correlation matrix is, how to generate them in Python. We began by focusing on the concepts of correlation matrix and the correlation coefficient. Then we generated the correlation matrix as a NumPy array, and then as a pandas or data frame also. Next we learned how to plot the correlation matrix and manipulate the plot labels labels, titles, etc. And we also discussed various properties used for interpreting the output correlation matrix. We also saw how we could perform certain operations on the correlation matrix, such as sortings the matrix, finding negatively correlated pairs, finding strongly correlated pairs, etc., etc. Then we discussed how we could use a covariance matrix of the data and generate the correlation matrix from it by dividing it with the product of standard deviation of individual features. Finally, we saw how we could save the generated plot as an image file. So we can go to check the pwd and our working directory. The pwd means present working directory. Run it and see that our present working directory is C user Deepak. So we can go to this C user Deepak, go to this PC, then go to C, go to users, go to Deepak, and go to breast cancer correlation, right? So this, if you see, click on this, you will see that an image will get created here, and we can see that. So this is how we can image of whatever we have done, and heat map is stored in your present working directory, whatever directory that you are working on. Let it come. Yeah, so this is the way you are going to get a heat map in a PNG file which is stored in your working directory, right? So we can finish this, go back to our working here, and this completes our this exercise, right? Thank you.